180 rule. Please remember in your calculator you have the angle menu to find your minutes, and then above the memory button or the plus sign you're going to have your seconds. You want to use that format. You want to give me DMS if I give you DMS. We can solve for angle B. Then we're going to set up an equation to solve for side C. Right? Again, we're going to use the given information. This is going to be my adjacent side, opposite side, and hypotenuse. In order that we were given the opposite side, to solve for the hypotenuse, we're going to use sine to set up our equation. The question is, how do we solve this equation? If we look at this like a proportion, a fraction equal to a fraction, don't we want to cross multiply and solve for C? So your next line of work should say something like C times the sine of 59 degrees 20 minutes is equal to 6.7, and then you divide both sides by what to solve for C? Yeah, you're going to divide by the sine of 59 degrees 20 minutes.
Where did they get minutes on seconds from?
Where they get it for time. Alright, when you put this into your calculator using DMS form, what do we get for side C? Anybody? 7.8. 7.8. If you didn't get it, try it now. Same thing here. Whenever you're solving for a denominator value, you're going to want to end up multiplying both sides by the variable, and then you're going to divide both sides by the tangent. For B, what do we get? 4. 4.0. Yes, sir.
If you find two sides, can you do the Pythagorean theorem?
Well, again, this comes down to significant figures. Didn't you round to the tenths place when you reported your answer? That can have a large effect when you're trying to do something exact. Okay, so those of you, especially who are going to go into engineering, you've heard of tolerances. A lot of tolerances go down to the thousands place. You can be like plus or minus 0.0005.
What should we round to?
A good rule of thumb when you're reporting answers going back is sides, I would say, can you go to the tenths? Angles, I would go to the hundredths. Alright, that's pretty across the board for these types of problems acceptable. Okay. Alright, let's move on to example 3. Alright, example 3, let's put a big star by this one. Example 3 is not a solve the triangle problem. The directions are only to solve for theta. Okay? Theta will be given to you or shown in a picture, written in words, etc. If this is my theta, the two sides I'm given represent OA or H. Which one represents which? 6 is now A, 11 is H. So the fact that I gave you those two sides tell you the trig function you must choose. What relates A and H? Cosine. So cosine, again, we're writing a trig equation. Cosine is the trig function. Do I know theta? No, not yet. So I'm going to put in theta here. And I'm going to say 6 over 11. Now, I understand that this problem doesn't say anything about inverses, correct? But what is it that I am solving for in the problem? In the trig equation, what am I solving for? Theta. Theta is in degrees or radians, correct? Since it's a theta, it's going to be, you're going to solve for degrees. So do you understand that by looking at the equation, I gave you the ratio, I want you to find the angle? That is an application of inverses. There is nothing here that says arc cosine. There is an inverse function, but we can write it by saying, I would like this to be solved in order to find the angle. So put it in your calculator, tell me what you get. .94 degrees. That's the measure of this angle. Once I have this as 56.94 and I have a right angle, do you see how now it became like example 1 and 2, I can solve everything else in the triangle? Yes? So for some reason when students get to this in their homework, they're like, I don't have enough information, I'm going to stop. No, you do have enough information because it's a right triangle, you can write a trig equation and solve for your angle. Alright, let's move on.
So you just do the inverse?
I used the inverse, correct, because I gave you the ratio and wanted to find the angle. Right. And you recognize that in the real world, these triangles represent quadrant 1, right? Because you don't have negative distances. So it's never going to be a problem. You're always going to be working within quadrant 1. Your answers should be acute angles between 0 and 90. To make sense. All right, so hot air balloon. Take a second to read the problem. 2/3 of your test is word problems, so this is the first one like it. The good news is you get to make really cool, cute drawings. Alright, so the context of the problem is important. We're talking about a hot air balloon which goes up in the air. We're talking about a ground crew that drives along the ground. Key idea, all of your drawings should have right triangles involved. Okay, so we're not blowing the airplane this way right now and the crew's driving up a mountain. Okay, we're just very simplified problems at this point. Moving forward. Right? So here is an example of what your drawing could look like. Do you want colored pencils? That would be okay. If you want to draw the hot air balloon, that would be fun. Ground crew, happy people driving away. You maybe drew yours the other way where the car's driving, that's fine. But the idea here is, can you draw a picture that represents what's going on in the story, but can you also label the parts based on the given information and know what you need to solve for? So the ground crew drove 1.2 miles. They looked back at the balloon at an angle of 30 degrees. They want to know, how high is the balloon at that moment? We are not going to throw a rope down and then measure the rope. If I set the triangle up correctly, does H mean hypotenuse? H stands for height, correct? This is height. 30 degrees is my theta. I know 30. This is going to be my adjacent side and my opposite side. What ratio relates A and O? Tangent. Tangent is my ratio. Do I know the angle? Yes, it's 30 degrees. Tangent is O over A, so I'm going to have my height over 1.2. Use your calculator. This is one of the easy ones to solve with the proportion. Multiply both sides by 1.2. What do I get? What did you get? 0.693. What are the units? Miles. So we're almost 3/4 of a mile high at this point. Any questions on that? All right, you have homework number 56.